Hello everyone, myself Sravanthi, working as a assistant professor in cybersecurity and data science in MLR Institute of Technology. Today our topic is non-deterministic finite automata. In that we are going to discuss what is non-deterministic finite automata and what are the examples of NFA. So non-deterministic finite automata, NFA stands for non-deterministic finite automata. It is easy to construct an NFA than DFA for a given regular language. So it is nothing but if we have a regular language or if we have a string, to construct that, it is easy to construct an NFA when compared to DFA, as we have already discussed DFA. The finite automata are called NFA when there is many paths for specific input from the current state to the next state. So here in NFA there is no restriction that it should have compulsory 2 inputs or the given input, the number of inputs, there should be a transition. But coming to here in NFA, there is no restriction. We can have either 0 inputs or 1 input or multiple paths that can be exist in NFA. So that is the reason we are going to tell that NFA is easy to construct when compared to DFA. Every NFA is not DFA, but each NFA can be translated to DFA. See here, NFA is not DFA because in DFA we will have compulsory 1 transition should be there. But coming to here in NFA, there is no restriction that for every input there should be some transition. So that is the reason we can tell that NFA cannot be a DFA. NFA is not a DFA, right? So, but each NFA can be translated to DFA. So, there are different types of conversions are there to convert NFA to DFA. The two conversions we are having is NFA with epsilon to DFA, epsilon NFA to NFA, and NFA to DFA. So, these are the conversions. By using these conversions, we can convert it into DFA. So, NFA is defined in the same way as DFA, but with the following 2 exceptions. There are 2 exceptions are there. The same tuples are going to be there in NFA as well as in DFA, but there are 2 exceptions are there. So it contains multiple next states and it contains epsilon transitions. In NFA diagram, we will be having multiple next states and meanwhile it contains an epsilon transition. So what does it mean is nothing but here in DFA we don't have epsilon transitions. Nothing but epsilon is nothing but empty symbols are not allowed. For example, we are going to take one diagram, Q0, Q1, Q2. Suppose this is my final state and there is an input of A and there is an input of B, A and B. See here the input symbols I am going to have are A, B are the 2 input symbols I am going to have. A, B are the 2 input symbols. But coming to here in DFA diagram, that is not allowed. But in DFA diagram, this is not allowed. Why? Because in DFA, there should be 2 transitions should be there. Because 2 inputs are there, 2 transitions should be there. Nothing but one A is there, Q0 on A and Q0 on B. There should be some transition. Either it should be on self or it can move to the other state. For example, here I am having B. Okay, so then here still the Q1 is not in a DFA. So to convert it into DFA, again there should be transition on A and on Q2 some A comma B. Then we can tell that this is a DFA. Why? Because for each state there should be 2 transitions. Why? Because here my input symbols are 2 input symbols are there. This is for DFA. But coming to NFA there is no rule that for each state there should be 2 inputs. There is no rule that for each state there should be 2 inputs. That is not a rule. So we can have many paths. We can have many paths for a single input. See here Q0, Q1. Same diagram I am taking Q0, Q1, Q2. Here I am having A and the same thing I can have same input for other state Q2 and same input I can have for same state. So nothing but Q0 on A input, it is moving to Q1 and it is moving to Q2 and it is moving to Q0. So nothing but what it is having multiple paths. It is having multiple paths. But again one more thing is there that there is no restriction that it should have each and every transition, each and every input transition. See here Q0 on B, there is no transition. Q1 on B, there is no transition. Q2, there are no transitions on A and B. So this is nothing but NFA. This is nothing but NFA. I can move from Q1 to Q2. Here I am having Q1 to Q2. There is no input path. Nothing but I can have epsilon transitions are also allowed in NFA. But these epsilon transitions and multiple next states are not allowed in DFA. That is the difference for NFA and DFA. Clear? So here in transition function, the only difference for transition function here is in NFA and DFA is there exist 5 tuples in NFA, there exist 5 tuples in DFA, but the only difference we are going to have is transition function. In DFA we are going to have Q cross sigma tends to Q. Q is nothing but number of states. State on input, it is moving to some state. Nothing but current state, input, and it is moving to new state. This is for DFA. But coming to NFA, the only difference is Q on sigma, it is having 2 power Q. Nothing but power set of Q elements are there. Nothing but power set of Q new states are going to be there. So this is the only difference we are going to have in NFA and DFA. So this is about DFA. So we will look on the examples here. So the first one is example of finite automata. So construct NFA for the language L which accepts all the strings over sigma equal to 0, 1 where string ends with 0, 1. So till now we have constructed a language. Based on the language we are going to draw a diagram. DFA diagram we have done. So now here in NFA. So what it is, it should end with 0, 1. So nothing but ending is 0, 1. I can have the starting, either I can have 0 or I can have 1. It's a combination of 0 or 1. See here, the language we can construct for this is 0, 1, 1, 0, 1, 1, 1, 0, 1, 0, 0, 1, 1, 0, 1, 0, 0, 1. All these strings are accepted. So for this we will construct a language, NFA diagram. Q0, 1 state, Q1. Here I am having 2 length strings, so I am taking just 3 states. Q0, Q1, Q2. So what it is, I am having ends with 0, 1. 0 and 1. So the starting is the start state. Q0 is my starting state. Q2 is my final state. So what I am having, 0, 1. The first string is accepted. So the next I am having is 1, 0, 1. The ending should be the 0, 1, that is fixed. So I can have the starting, I can have 0 or 1. It's a combination of 0, 1. Multiples of zeros or multiples of ones can be taken here. So this is for a string ends with 0, 1. Why I can't keep here 0, 1? Because see here, if I keep here 0, 1, the string it reads is 0, 1, 1, 1 string can be read. But what it is, my condition is it should end with 0, 1. But it is ending with 1, 1. So that is the reason here we are not keeping a self loop of 0, 1. So that is the reason we are not using this. Okay. So this is the diagram for NFA. So what are the tuples I am going to have? So what are the tuples? Q, sigma, delta, Q0, F. These are the 5 tuples I am going to have. So Q is nothing but number of states. What are the number of states I am having? Set of states. Q0, Q1, Q2. Next, sigma is nothing but number of input symbols. 0, 1 are the input symbols. And delta transition. Next I am having is Q0. Q0 is nothing but my starting state. What is my starting state? Q0 is my starting state. So F is nothing but final state. Here according to this diagram, final state is Q2. How I am going to identify final state? It is with 2 circles. So the next one I am having is transition function. So the transition function I am having is here is what are the number of states I am having? Q0, Q1, Q2. What are the input symbols? 0, 1 are the input symbols. Q0 on 0. There is a transition on Q1, Q0. And the next one is Q0 on 1, Q0. Next Q1 on 0, there is no transition. So nothing but pi or empty. Next Q1 on 1, it is moving to Q2. So Q2 on 1, nothing. Q2 on 1, nothing. So pi is nothing but epsilon, nothing is there here. So there is no transitions for Q2 state. So this is for transition diagram for the NFA. So the next sim. Construct NFA for the language L which accepts all the strings over alphabet sigma equal to 0, 1. So where substring is 0, 1. So the condition is I need to have a string. In that string the substring should be 0, 1. I can have starting anything and ending anything. But in that should have a substring of 0, 1. The substring should be 0, 1. So nothing but I can have in the starting 0, 1, 0 or 1 or multiple zeros or multiple ones or combinations of zeros and ones. In the ending also zeros or ones or combination of zeros and ones. So these will be the string. So what will be the language for it? So 0, 1 is accepted, 1, 0, 1 is accepted, 1, 0, 1, 1 is accepted because 0, 1 is existing. 0, 1 is existing. So I can have 1, 1, 0, 1, 0, 0. Yes, it is accepted. So on. What type of language it is? Infinite language. It is a infinite language. It is a infinite language. Let us construct a NFA diagram for it. Q0, Q1, next Q2, 0, 1. And Q0 is my starting state. Q2 is my final state. Q2 is my final state. So 0, 1. The string is going to be accepted. So what it is? The string should contain a substring, nothing but 0, 1 should be the substring it should have. So either I can have in the starting 0, 1 and ending also I can have 0, 1. Ending also I can have 0, 1 as a substring. See here, based on this diagram, it accepts 1, 0, 1, 1. Check it 1, 0, 1. Q0 on 1, it is moving to Q0. Q0 on 0, it is moving to Q1. Q1 on 1. Sorry, Q1 on 1, it is moving to Q1. Next Q1 on 1, it is moving to Q2. So it is reaching my final state. Nothing but the string is accepted. The string is accepted. Same, let us check for 1, 1, 0, 1, 0, 0. Let us check for this string whether it is accepted or not. See here, Q0 as it is my starting state, I am going to take Q0, 1, 1, 0, 1, 0, 0. So Q0 on 1, where it is moving? Q0. So 1, 0, 1, 0, 0. So Q0 on 1, where it is moving? Q0. Q0, 0, 1, 0, 0. So Q0 on 0, where it is moving? Q1. Q1, 1, 0, 0. Q1. So Q1 on 1, it is moving to Q2. Q2, 0, 0. So Q2 on 0, it is moving to Q2 on 0. So Q2 on 0, it is moving to Q2. So once it is reaching this final state, nothing but we can tell that the string is accepted. We can tell that the string is accepted. So this is about the string contains a substring 0, 1. You can have any elements as an input, A, B, B, A, anything. The procedure is same. So the next one. Construct NFA for the language L which accepts all the strings over alphabet A, B where the third symbol from right end is A. Where the third symbol from right end is A. From the right side, the third symbol should be A is my condition. So this is my first symbol, second symbol, third symbol. The third symbol should be A. The fourth symbol or fifth symbol can be anything, either A or B. And the second can be A or B, anything. The first can be A or B, anything. But the condition is that from the right side, the third symbol should be A. From the right side, the third symbol should be A. This is our condition. So, based on this, we are going to construct a diagram. So, whatever it may be the language, we should have the third symbol as A. The third symbol in a string should be A. For example, ABB is accepted, BABB is accepted because the third I am going to have is A. For example, if I take BBB, this string, will this string is accepted by this language? No, it is not accepted. Why? Because here I am not having the right end, third part is A. A is not there. So that is the reason this string is not accepted. So let us construct a NFA diagram. Q0, Q1, Q2. As the third symbol is A, I'm going to have 4 states. Q3. First, second, third. First, second, third. Third symbol is A. Third symbol is A. Q3 is my final state. Q3 is my final state. So what it is? The third symbol is A. I can have here A or B. Here also I can have A or B. And I can have here A comma B. Anything. So A, B, B. The strings which are accepted by these is A, B, B is accepted. 4A's is accepted. All these are accepted. I cannot place here loop. Self loop cannot be placed. A comma B or A, B, anything. Why? Because if I keep here, the third string won't be this one. See here, how I can read A, B. I can read B, B, B. See here, I am getting the third symbol as B. Why? Because here self loop is nothing but it can read any number of times, A's or B's. So that is the reason here I am not using here A comma B. A comma B is not used. So this is the string for where the third symbol from right end is A. Construct NFA for the language L equal to AB whole power N with N greater than or equal to 1. They gave here one language. That language is having AB whole power N with N greater than or equal to 1. With N greater than or equal to 1. So nothing but N starts from 1. So AB whole power 1 is nothing but AB. AB whole power 2 is nothing but what it reads? AB, AB. This is a string it reads. If I have AB whole power 3, AB, AB, AB. So these all the strings should be accepted by NFA diagram. These all the strings should be accepted by NFA diagram. So let us construct it. So Q0, Q1, Q2. Q0, Q1, Q2. So this Q2 is my final state. What is the string I am having? AB. Basic string I am taking. AB. So this is the first string it is accepted. A. Q0 on A, it is moving to Q1. Q1 on B, it is moving to Q2. So the string is accepted as it is reaching my final state. So the next one is AB whole square. AB whole square. Nothing but AB, AB. So it reads AB, AB. So if I keep here AB, A, it reads, let us check it here. Q0 on AB, AB. Q0 on A, where it is moving Q1, B, AB. So Q1 on B, it is moving to Q2 AB. So Q2 on A, it is moving to Q1. Q1 on B. Q1 on B, it is moving to Q2. So the string is accepted. As it is reaching my final state, the string is going to be accepted. So the same way, you check for AB, AB, AB. The same thing repeats, the string it accepts. Q0 on A, it is moving to Q1. Q1 on B, it is moving to Q2. Till here it is done. Let me do Q0 comma AB, AB, AB. Q0 on A, it is moving to Q1. Q1 B, A, B, A, B. Q1 on B, it is moving to Q2. Q2 A, B, A, B. Q2 on A. Q2 on A, it is moving to Q1. Q1 B, A, B. Q1 on B, it is moving to Q2. Q2 comma A, B. So Q2 on A, it is moving to Q1. Q1 on B. It is moving to Q1 on B. Where it is moving? It is moving to Q2. So when I complete reading my string, it is reaching the final state. It is reaching the final state. This is for NFA construction. Same 5 tuples are there. The transition diagram, same. So the next one we are having is L equal to AB whole power N. They gave a language L equal to AB whole power N, and the condition is it should start N greater than or equal to 0. So let us check. So N starts from 0, 1, 2, so on. 0, 1, 2, so on. So what it is? AB whole power 0. AB whole power 0 is nothing but nothing is there. Nothing but epsilon. Epsilon. So the next one is AB whole power 1. AB whole power 1. What it is? AB whole power 1 is AB. AB whole power 2 is nothing but AB, AB. AB, AB. AB whole power 3 is nothing but AB, AB, AB. AB, AB. So these are the languages that comes for this condition in a language. So the difference for the previous one and here is, there we are having n greater than or equal to 1. Here we are having n greater than or equal to 0. So Q0, Q1, this is my final starting state. As n equal to 0, it is nothing but the starting state will be our initial final state. Why? Because it ends there only. Right? So that is the reason it is ending there. So the final state, when I give any AB, nothing but epsilon. So the start states and end states is pointing to same. So the next one, AB whole power 1. A, as Q0 is my final state, so I am taking only two states. B, AB. So see here, AB is nothing but Q0 on A, it is moving to Q1. Q1 on B, it is moving to Q0. So the Q0, it reaches my final state. So the string is accepted. So let us check for the next one. AB whole power 2. Nothing but AB, AB. So Q0 on A, it is moving to Q1. Q1 on B, it is moving to Q0. Q0 on A, it is moving to Q1. Q1 on B, it is moving to Q2. So this string is also accepted. So the NFA diagram is fine. It is working clear. So same transition, 5 tuples are there. The delta transition function. So number of states, that many we are going to write. So this is about NFA with the examples. In the next coming class, we will discuss about the conversions of NFA with epsilon to NFA and NFA to DFA. Thank you.